From the snow-capped peaks of towering mountains to the icy depths of frozen lakes, our world is a tapestry woven with extremes. And in these unforgiving landscapes, where temperatures plummet and life seems impossible, there exist creatures that defy the very limits of survival. Creatures that possess the remarkable ability to freeze solid, their bodies locked in an icy embrace, only to thaw and stir back to life when conditions improve. Tiny creatures, no larger than a grain of sand, lie dormant, their bodies transformed into miniature ice sculptures. These are the tardigrades, microscopic marvels that can withstand temperatures so low that most life forms would crumble. Join me, dear viewers, as we embark on a journey into this extraordinary world of frozen animation, where we'll uncover the secrets of these resilient creatures and explore the tantalizing possibility. Could humans one day possess the same astonishing ability to cheat death's icy grip? Our first stop takes us into the microscopic realm, where we encounter the tardigrade, a creature so resilient that it borders on the unbelievable. These microscopic marvels, also known as water bears or moss piglets, are found in virtually every corner of the globe, from the highest mountains to the deepest oceans and even the most arid deserts. Don't let their diminutive size fool you. Tardigrades are masters of survival, capable of withstanding extremes that would obliterate most other life forms. When faced with freezing temperatures, these microscopic marvels employ a remarkable strategy known as cryptobiosis, essentially hitting the pause button on their biological processes. As temperatures plummet and ice crystals begin to form, tardigrades replace the water in their cells with a type of sugar called trehalose. This acts as a natural antifreeze, preventing the formation of damaging ice crystals that could rupture their cells. In this state of suspended animation, their metabolism slows to an almost undetectable level, their bodies becoming as inert as grains of sand. They can remain in this frozen state for decades, perhaps even centuries, patiently waiting for conditions to improve. And when the ice finally melts and temperatures rise, something truly astonishing occurs. The tardigrades, as if reawakening from a deep slumber, spring back to life. Their bodies, once locked in an icy grip, resume their normal functions, and they continue their microscopic lives as if nothing had happened. These tiny creatures are a testament to the power of adaptation, their resilience a source of both wonder and inspiration. Scientists are studying tardigrades closely, hoping to unlock the secrets of their remarkable resilience. Understanding how these microscopic marvels survive freezing temperatures could have far-reaching implications for fields such as medicine, cryogenics, and even space exploration. Venturing from the microscopic world to the larger creatures of our planet, we encounter another group of animals that have mastered the art of surviving freezing temperatures. Frogs. Unlike mammals and birds, which maintain a constant body temperature, frogs are ectotherms, meaning their body temperature fluctuates with their surroundings. While this makes them vulnerable to extreme temperatures, certain frog species have evolved an incredible adaptation to survive harsh winters. As temperatures plummet and their watery homes begin to freeze over, these frogs enter a state of dormancy known as brumation. Unlike hibernation, where animals remain in a deep sleep throughout the winter, brumation is a more shallow state of dormancy. The frog's metabolic rate slows significantly, their heart rate and breathing become almost imperceptible, and their bodies produce a natural antifreeze. This antifreeze, a type of glucose, prevents the formation of large ice crystals within their cells, which would otherwise be fatal. Instead, ice crystals form around the outside of their cells, essentially encasing the frogs in a protective layer of ice. In this frozen state, they appear lifeless, their skin cold and rigid. But beneath the surface, a flicker of life remains. Their vital organs, protected by the natural antifreeze, continue to function at a minimal level, sustaining them throughout the winter months. When spring arrives and the ice begins to melt, the frogs miraculously thaw and reanimate. Their hearts begin to beat again, their lungs fill with air, and they emerge from their icy slumber, ready to hop back into the world. This remarkable adaptation allows these frogs to survive in environments that would be impossible for other amphibian species. The study of frog brumation is of great interest to scientists, as it provides insights into the mechanisms of cryopreservation, the process of preserving cells and tissues at extremely low temperatures. Understanding how frogs survive freezing could one day lead to breakthroughs in organ transplantation and the treatment of diseases. Their ability to freeze and thaw, seemingly defying death itself, serves as a powerful reminder of the incredible resilience of life on Earth. Our journey into the world of frozen animation takes us deeper into the soil, where we encounter another group of creatures that have mastered the art of cryobiosis, nematodes. These microscopic worms, often overlooked due to their size and subterranean lifestyle, are masters of survival, capable of enduring extreme conditions that would spell doom for most other life forms. Nematodes are found in virtually every habitat on Earth, from the tropics to the poles, and even in the depths of the ocean. They play a crucial role in many ecosystems, breaking down organic matter and cycling nutrients through the soil. When faced with freezing temperatures, nematodes employ a strategy similar to that of tardigrades, entering a state of cryptobiosis. They expel most of the water from their bodies, replacing it with a sugar-based antifreeze that prevents the formation of damaging ice crystals. In this dehydrated and frozen state, their metabolism grinds to a halt, their bodies becoming as inert as grains of sand. They can remain in this state of suspended animation for years, even decades, patiently waiting for conditions to improve. What's truly remarkable about nematode cryptobiosis is that it's not simply a state of dormancy. They don't age, they don't require any sustenance, and they emerge from their frozen slumber virtually unchanged. Scientists are fascinated by nematode cryptobiosis, as it offers a unique window into the mechanisms of aging and cellular preservation. By understanding how these microscopic worms can essentially stop time, researchers hope to develop new methods for extending lifespan and combating age-related diseases. For now, nematodes stand as a testament to the incredible diversity and resilience of life on Earth. Their ability to freeze and thaw, seemingly defying the passage of time, serves as a powerful reminder that even in the harshest of environments, life finds a way. Our final stop on this journey into the world of frozen animation takes us to salt lakes and brine pools, where we encounter another group of creatures that have evolved a remarkable strategy for surviving extreme conditions: brine shrimp. These tiny crustaceans, often sold as novelty pets known as sea monkeys, are masters of adaptation, capable of thriving in environments that would be lethal to most other life forms. Brine shrimp are extremophiles, meaning they live in environments with extreme conditions, such as high salinity, extreme temperatures, and low oxygen levels. They are found in salt lakes and brine pools around the world, from the Great Salt Lake in Utah to the Dead Sea in the Middle East. When faced with harsh conditions, such as drought or freezing temperatures, brine shrimp employ a remarkable survival strategy. They produce cysts, which are dormant eggs that can withstand extreme conditions. These cysts are incredibly resilient, capable of surviving for years, even decades, in a dried and frozen state. When conditions improve and water returns to the lake, something truly astonishing occurs. The cysts, as if awakened from a deep slumber, hatch, releasing a new generation of brine shrimp into the world. Within hours, the lake teems with life as the tiny crustaceans swim, feed, and reproduce. The cysts' ability to withstand extreme conditions is truly remarkable. They can survive being frozen solid, boiled in water, and even exposed to the vacuum of space. This resilience is due to a number of factors, including their tough outer shell, their ability to dehydrate themselves, and the presence of protective proteins within the cysts. Scientists are studying brine shrimp cysts to better understand the mechanisms of dehydration tolerance and DNA repair. This research could have implications for a wide range of fields, from agriculture to medicine. Imagine, for example, being able to develop crops that are more resistant to drought or frost. Or perhaps we could use the secrets of brine shrimp cyst preservation to develop new methods for storing and transporting vaccines and other temperature-sensitive medications. Brine shrimp, with their remarkable ability to survive extreme conditions, serve as a powerful reminder of the incredible resilience of life on Earth. From the microscopic tardigrade to the resilient brine shrimp, the natural world is brimming with creatures that possess the remarkable ability to freeze and thaw, seemingly defying death itself. Their incredible adaptations serve as a testament to the power of evolution, showcasing the astonishing ways life can thrive even in the face of seemingly insurmountable challenges. These creatures not only spark our curiosity but also offer valuable insights for scientific exploration. By studying their cryobiotic abilities, we gain a deeper understanding of cellular preservation, DNA repair, and the very essence of life itself. Who knows what breakthroughs await us as we continue to unlock nature's secrets? The question remains, could humans one day harness the power of freeze and thaw? Could we, like these incredible creatures, unlock the ability to pause and restart our biological clocks? While the answer remains shrouded in the unknown, the possibilities are as tantalizing as they are profound. Us humans? Not quite there yet. We can't freeze and wake up again. For now. But who knows? Maybe in the far future, thanks to medical technology, we'll wake up, watch this video and go, "Hey, that's me." What about you? Would you want to freeze yourself and come back in the future? Tell us in the comments. We can't wait to hear your survival strategies. And of course, don't forget to subscribe for more fun and frosty adventures.